Good afternoon, everybody. I'm Dr. Caroline Simpson. I'm an astronomer here at FIU. I've been here for mumble years. And I was asked to speak because before I went to graduate school and after I got my bachelor's degree in astronomy, I went and I worked at the Hubble Space Telescope Science Institute. And I am so old that I was there before the telescope was launched. And I worked on something called the Guide Star Catalog, which is the map that the Space Telescope uses to point itself. I was in graduate school when it was launched, and I remember going to professional astronomy conferences when the Hubble data started coming out. And I was at this conference, and they had a display. They had like a standalone wall, and they had taken a picture of what is known as the Hubble Deep Field, which is just hundreds and hundreds of galaxies in this much space, and they put it as a wallpaper. And there was sort of a crowd around it with a bunch of astronomers doing this, including me. One of my colleagues who still worked at the Institute said to me, "There's so much data, so much information, it's like trying to drink from a fire hose." Those images from Hubble that started coming down 30 years ago really revolutionized astronomy. We'd never had data like that before. And it just, our understanding of the cosmos just increased exponentially. So it's been really exciting to watch the data coming down from the new James Webb Space Telescope, which is doing the same thing again, even more so. I look at some of these images and I'm like, no, that can't be, what? No. What I do is I study star formation in very small galaxies. Star formation is how galaxies evolve, and small galaxies are the most common type of galaxy in the universe. So ultimately, what I'm interested in is how the universe has evolved over time. And both of these space telescopes have taught us so much about that. Some of these images, I'm like, okay, we know the answer now, I'm done. Really stunning, and I'm so excited that you're gonna be able to see some of these images today and have them put into their context. So before we do that, I'm very excited to introduce my colleague, FIU's own Dr. James Webb, believe it or not. No relation to the telescope, but that's okay. So Jim, you wanna come up?
I take full credit for it anyway. Just kidding. But basically, technology equals the new views of our universe, like Caroline mentioned. Every time we get an advance in technology, we see different things and we understand the universe a little bit better. And I started out as an optical astronomer, and I basically evolved through different frequency range. I study things called blazars, protogalaxies at the very edges of the visible universe. We first found them about 1960 using radio observations. The more we learned, the weirder they got. They're basically very distant objects out in the universe, supermassive black holes. They emit more radiation than about 1,000 galaxies, the size of our solar system. Have to be supermassive black holes. Nobody liked the idea of supermassive black holes, but they have to be, because that's the only thing that can generate that much energy. So I was fortunate to be riding the wave of technology. So we started out using optical telescopes with photographs. Anybody ever seen a photograph on paper? That's what we started out using before CCD electronic cameras. I was one of the first to be able to change to electronic cameras to actually do my research. Then they launched an ultraviolet telescope. I got to use the ultraviolet telescope to look at these objects. Then they launched X-ray telescope. I got to look at the X-ray telescope data to look at these objects. Infrared and finally gamma rays. So sort of like, my career is sort of like walking down a corridor, looking out a window. You see something in optical, the next window UV, next window X-ray, gamma ray, now eventually neutrinos and gravitational waves. So the more technology you have, the better view you get and the more things you discover. So the current picture right now is that what the objects I study look like. We've never seen one up close because they're billions of light years away, but we pretty much know what they are like because of these observations. So the future is here, the James Webb Space Telescope. It's going to offer high precision infrared observations of accretion flows. These supermassive black holes are driven by accreting stars and planets and basically emitting energy. So we're going to be able to look right down with unprecedented accuracy at these objects and see what they really are like. We do have here at FIU a JWST connection. The JWST PI John Mather came up to me at a AAS American Astronomical Society meeting one time and said, I heard you were here. I want to meet you, James Webb. My telescope's named after you. Of course, we had a good laugh over that. We became friends, and so we had dinner and lunch together every time we go to conferences together. And so I invited him here when we started our observatory. And he was our guest of honor for the dedication of our observatory. And our 24-inch telescope, if you've never been over there, you have to come by if you're local. It's informally called the James Webb Ground-Based Telescope. Because I wrote the grant to get the telescope, I chose the telescope to install, and I helped install it when they got here. And I actually used it last night from my couch. So it's really pretty neat. But we're really excited about the James Webb Space Telescope. I've been telling my observational astronomy classes for the last 3 years. And it's going to be amazing, and it is amazing. Every image I see is just, like Carolyn says, you see so much there, you just can't believe it's like drinking from a fire hose. That's a great analogy. So I think we're pretty much ready to go. Got a few more minutes? Okay. So basically, James Webb Space Telescope to be able to look at the early universe, very high redshifts. So redshift, basically, as the universe expands, it carries along with it galaxies and quasars and things like that. So the further, and as it expands, it basically extends the light out. It's called a redshift. So we looked at distant objects, we see them higher and higher redshifts. And that redshifts all the information into the infrared part of the spectrum. That's where the James Webb Space Telescope is built for. It's going to actually look into that part of the spectrum, so we're going to be able to see these galaxies when they're first being assembled. We're going to also be able to see what I'm excited about, spectral lines in planetary atmospheres. See if there's alien life out there. I just gave a public lecture on alien life. Is there any life out there? One person asked me, what do you think? My answer is, it doesn't matter what I think. We have no evidence that it exists. Until we find evidence, then it's not a question. So we know the chemicals are there. We know the conditions are there. We don't know how life first exists, how life was created here on Earth. So once we figure that out, how life began here on Earth, then we may be able to answer the question, is there life out there? Or if we discover chemicals in the atmosphere. So basically, every technological advance, such as JWST, opens a new window to understand parts of the universe we could only imagine before. And everybody asks me, why do you study blazars? They're so far away. How can they have an effect on us? They're the most extreme laboratories for physics that we know of in the universe. So once we understand the extreme, we learn more about everything. And gives us knowledge about how galaxies are created. And that's what I call the grand scheme of things. So I guess it's about time now. I should probably, we're going to go to the Space Center now, the Hubble Science Institute, and hear from the actual James Webb people. So, thank you.
Thank you, James. I really appreciate that introduction. Can everyone hear me okay? I just want to make sure we sound good. All right, I see some thumbs up from the audience. Thank you. That was a great introduction, and it sounds like James would be a great part of our team doing outreach. And I bet he's super excited that he can hop on the internet now and find swag with his name all over the place. That's got to be a nice thing. So I am going to share my screen real quick. So give me just a moment. So I'm going to go ahead and introduce ourselves. I want to say thank you to the organizers of the EdIT conference here at Florida International University. And thank you to everyone in the audience who's decided to join Kelly and me for this conversation today. It's a real honor to be able to get to speak with everyone. The topic of this conversation will be focused largely on WebbVR, which is an outreach product that we've created here at the Space Telescope Science Institute. We're in Baltimore, Maryland. I'm Chad Smith. I'm the head of the Web Development and Content Group in the Office of Public Outreach at the Space Telescope Science Institute. And I'm joined by Dr. Kelly Lepo. Kelly, would you like to introduce yourself?
Sure. Thanks for that, Chad. So yes, my name is Dr. Kelly Lepo. I'm an education and outreach scientist at the Office of Public Outreach, and I primarily support outreach efforts for the James Webb Space Telescope.
Thank you. And just a short introduction about the Space Telescope Science Institute. Again, we are located here in Baltimore, Maryland. We are the Science and Operations Center for the Hubble Space Telescope, and as everyone is now aware, the James Webb Space Telescope, which is the new kid on the block, but obviously making big waves out in the community with some of the amazing images that it's sending back. We also serve the science community and the public in their endeavors to explore and understand the universe. Kelly, would you like to talk about the Office of Public Outreach?
Ooh, sure. Yes. Thanks, Chad. So yes, both Chad and I are members of STSCI, the Space Telescope Science Institute's Office of Public Outreach. And we have three goals at the Office of Public Outreach. The first is to communicate, to share the science of NASA with the world. And to do that, we put out press releases, we make videos and education materials and different programs and work with people of all ages and backgrounds. The second goal we have is to engage, to visualize data from the Hubble Space Telescope and the Webb Space Telescope, and to make the beautiful images that you might see in the news or on social media. And we do this to inspire people. As one of my colleagues likes to say, astronomy and dinosaurs are the gateways to science. And that was certainly true for me. So I might be a little bit younger than the two people who introduced us. I was a kid in the 1990s when Hubble first launched, and seeing the first images or some of the first images from Hubble come back, the pillars of creation, watching comet Shoemaker-Levy 9 slam into Jupiter to see what happened. Those are really inspiring to me and inspired a lifelong love of astronomy. And eventually, I became a professional astronomer. So not everyone that sees a Hubble or a Webb image will become an astronomer, but maybe they'll be inspired to study a STEM topic, not necessarily, astronomy, maybe engineering or mathematics or medicine, or maybe it'll just be a hobby. Maybe you think that science is cool and that it's important and that it should be funded. And all of those are part of our goals for sharing these discoveries with the world. And the third goal is to broaden our reach, to ensure that we are reaching new audiences that are traditionally underserved by science outreach. And one audience that we've been focusing a lot on lately is the blind and visually impaired audience. You might think of astronomy as a really visual science, but we've been doing a lot of thinking about how we can share the wonders of the universe with people who cannot see it. And so over the past couple of years, we've really been working on improving the accessibility of our websites and other materials. So I'm going to talk a little bit about that, and then I'll hand things over to Chad, and he will talk a little bit about WebbVR. So next slide, please. So reflecting a little bit on the themes of this conference, one of them is innovation, right? And I'd like to propose that innovation is not necessarily using the shiniest new thing. It's not necessarily about the newest piece of technology or the latest piece of software. It can be about using the tools that you already have in new and innovative and surprising ways. So next slide. And another theme of this conference is inclusion, right? And so you can combine these two things, how can you use the tools that you already have to be innovative and inclusive? How can you tell the stories that you want to tell in new and surprising ways by repurposing existing technology and being very creative about how you use it? So next slide, please. So I'd like to share a little bit about some of the ways that we've tried to bring Webb's first images to the blind and visually impaired community as an example of inclusive innovation. So here we have a tactile display of Stephan's quintet. So Stephan's quintet is this group of interacting galaxies. And we partnered with a company that normally makes 3D representations of art for visually impaired audiences. And we partnered with them to make a display that is both beautiful and scientifically accurate and communicates the details of the image to both sighted and non-sighted audiences. So we can see the little bumps here in this one galaxy from Stephan's quintet. And that tells us that this particular galaxy is pretty close by, and you can actually resolve individual stars either with your eyes or with your fingers. Okay, next slide, please. Another way that we've been reaching out to this audience is through the use of alt text. And we've actually gotten really great feedback from the community about how we've done this. So alt text is not new. It's a thing that hold over from the early internet. Alt text is used by people who use screen readers. So when a screen reader encounters an image, it will read the alt text instead of showing the image. And we've been trying to do new things to communicate the awe and beauty of Webb's first images with people who cannot see them. And we're trying to be both a little bit poetic, but also scientifically accurate. So I'll read a little bit of this. This image is divided horizontally by an undulating line between a cloudscape forming a nebula along the bottom portion and a comparatively clear upper portion. Speckled across both portions is a star field showing innumerable stars of many sizes. The smallest are small, distant, and faint points of light. The largest of these appear larger, closer, brighter, and more fully resolved with 8-point diffraction spikes. The upper portion of the image is bluish and has wispy, translucent, cloud-like streaks rising from the nebula below. The orangest cloudy formation in the bottom half varies in density and ranges from translucent to opaque. Right? It's very beautiful, it's very poetic, and we really heard from a lot of blind people who were really happy to go on this journey with us through this alt text. Okay, and so then next slide. The final way that we're trying to share the universe with different audiences is through sonification. So this is playing now, and this is translating pixels into tone. And we're watching as a bar sweeps across the image. You hear one boop right there from the central star inside this planetary nebula, the Southern Ring Nebula. On the left is a near-infrared view, and we're going to move shortly into the mid-infrared view into longer and redder wavelengths. And one cool thing that you'll hear here as the bar hits the center of this image is you'll hear two little boops. And that's from the two central stars that you can see in mid-infrared light or here in the sonification. And that's because one of those central stars was so shrouded in dust, it only comes out in mid-infrared light. So just to be clear here, we're not listening to the sounds of space. Rather, we're taking light and we're translating it into sound. We're creating a different way to experience and interact with the universe. So then switching gears a bit, I'm now going to hand things over to Chad, and he'll talk about another innovative way that we have leveraged existing tools for learners to interact with the universe and experience the Webb mission and Webb science.
Great. Thank you so much, Kelly. I appreciate that. And so I'm going to speak with everyone about a product that is near and dear to me, and that is called WebbVR. Being that this is a conference focused in part on innovation, I would assume that most everybody knows what VR is. But let's take a moment and ask ourselves, what is VR, or virtual reality? Typically, when I first mention the idea of VR to someone, the first thing that they think of is the hardware, which is that big old brick that people wear around on their head, and it looks a little bit silly. But just like a radio delivers a song, or a book delivers words, or a big screen delivers a movie, a VR headset is simply another means for communicating a story. And so without a compelling story, the medium that we choose really isn't too relevant. Technically speaking, virtual reality is a simulated experience that employs pose tracking and 3D near-eye displays to give a user an immersive feel into a virtual world. And for most people who have never tried virtual reality, the first image that might come to mind is maybe something like this. Or for those who have tried VR, maybe it's a memory that they have from the experience, something like this. But for those of us who get to create that compelling virtual story about space telescopes in the universe and share that experience with the world, for us, it's more like this. You know, we take this product out to conferences and we get to interact with people in the public and share with them the discoveries that this telescope is going to be making. And we get to do it in a way that the user is able to move around and interact in the environment. And I ask myself sometimes, is VR really particularly innovative? In fact, the medium for the communication, it's really been teasing audiences for decades. It's been promising to usher in an era of exciting new worlds to discover. But a lot has changed in the decades since the VR technology, the headsets itself, has really been introduced. And the biggest thing that's changed is the ability of computers to really render that superior quality video at high frame rates and the optics that are able to make it look great and give you a truly immersive experience. And so we really are at a point where this technology has become a really truly effective means for communicating information that wasn't possible in the past. What we have now is a technology that gives us the ability to bring visually stunning, immersive learning environments to our users where they can explore, engage, and experience the universe like they never have before. And I might be a little bit biased, but I think space is really the best virtual story that we can tell to people. And James Webb is a great way to do it. Now, I did touch on a number of reasons why virtual reality is great. But another reason is that Webb is extremely big. This picture is Northrop Grumman's full-scale model of the telescope. And so when we were looking to communicate just sort of the scope of the size of the engineering of this telescope, Northrop would pack up this model and they would ship it around the country and sometimes around the world. And that's a really difficult thing to do. Yeah, and there's a picture of my daughter down in the bottom left corner. She's much bigger now. Going to see it. And so that just kind of gives you a sense of the scale. And I had long heard about how big the telescope was, but seeing it in person really drives home the point. And no matter how much people would tell you about the enormity of the mirrors and how powerful they would be, it was really hard to imagine quite how big they were until you were standing in front of them. And so nobody wants to have a tool like this to bring the telescope to people, when we have a tool like this that could do the same thing. So how could we bring Webb to the palm of everyone's hands? And virtual reality seemed to be a really great match for that. And so in the spring of 2015, while I was working on my master's degree in information visualization, I had the idea for WebbVR, the James Webb Space Telescope virtual experience. And the concept was fairly simple: to create a tool that leverages virtual reality technology to engage and educate audiences by allowing them to interact with Webb in a way that was fun, exciting, and exploratory. And those fun, exciting, and exploratory points are really important here, because WebbVR is just perfect for this. VR is perfect for this. And so, equipped with a crude 3D model and a fair amount of coding experience and a healthy dose of ambition, I set about creating a virtual learning environment to teach people about the James Webb Space Telescope. And after a bit of user testing and learning what works and what doesn't work in VR, we started to develop all the areas of focus that would really create that fun, exciting, and engaging environment. And so this is a list of some of the goals and techniques that we've employed in the development of WebbVR. And after I run through this, I'll do a quick, maybe 10, 15 minutes video stream of the application itself. And with the caveat that it's really not the same as putting it on and wearing it and having full control and being able to fly around the environment. But we'll touch on some of this. So the goals that we have are really to make use of three-dimensional space, location, size, scale, distance, shape, structure, and time are all really great things that a user can explore. Make it exploratory. Allow the users to have control. We're not going to guide them through it. We're going to let them fly around the environment and experience the telescope and its discoveries on their own. But there are times when we need to make it explanatory as well. Some of the concepts of, for example, exoplanet discoveries and the type of different ways that the telescope will be able to make those discoveries can be complex. So we want to step the users through what that process looks like. We really want to engage our users with interactivity and make it something that they want to play with. We want to broaden our audience, so we've included multiple languages in here so that we're reaching as many people as we can. Accessibility, inclusion. VR is maybe not the most inclusive piece of technology that there is, but we still consider it in all the design decisions and the mechanics that we use in the system. It's always forefront in our thinking. And to really create stunning visual effects, because there's emotion in this. As Carolyn stated earlier, when she stood in front of the deep field image and she was just moved by that image, I have very similar feelings. And it's one of the reasons I always felt so honored to be working here, because that image really evokes an emotion about who we are and where we are and our place. And so VR is really great at this, to replicate environments that a user will never be able to experience and to make it natural, so that someone is able to just pick this up and fly around. And I'm going to pass the control over to the organizers of the event, because we have some videos we're going to run. And so again, apologies if it's a little bit jumpy. It's not like it's not a Hollywood camera that we're wearing on our headset. But this is a screen video grab from the WebbVR experience. And what you're seeing right now is one of our users flying around the environment. They're in free control of being able to move around this environment. So whatever direction they are pointing their controller and pulling that thruster on the controller, they're moving in that direction. So you can see that someone has the ability to really move around and get a sense of scale of the telescope. We've built in a number of animated sequences here. So this is an example of sort of that explanatory learning that we're doing in here. We're layering in content. So this is an animation that's showing how the sun shields work. So you can see the orientation of the telescope. We tend to think of it sitting upright, but it's tilted to the side so that the sun shield is able to protect the instruments from the heat of the sun. And now our users decided that they're going to fly away. And the further they fly away, you can get a sense of scale of where the telescope is in relation to the Earth, the sun, other planets in the solar system. And so this is where we start to get into this exploratory nature, right? Giving users a sense of their place within our solar system, and being able to explore our local environment. And in this application, we have a full replica of our solar system, all the planets. Most of the major moons are in here. I think our user's at Dione now, and now flying back away. And I'm just going to let it roll through a little bit, and let's see. And to the point of engaging users with interactivity and making things natural, we can talk a little bit about our control system here. So yeah, I don't know if you've been able to see, but every once in a while, a controller pops up in the screen. That controller is used by our user to be able to direct where they want to fly to. So they point it in the direction that they want to move, and they pull a trigger and they fly in that direction. But we noticed pretty quickly that traveling can be a difficult thing. So we gave users the ability to quickly lock on to different points of interest that they want to go to, select another button, and it'll zip them across the scene. Here we're showing an idea of some more of the interactivity. Each of those planets that you go to, a user is able to see how much they would weigh at that object. And so, would it be possible to turn down the volume on the videos by chance?
Horizon. As it ingests,
but I can talk over that for a second. So this is actually part of our accessibility as well. So in addition to having audio that introduces you to each one of the scenes, we also have on our controller menus on the left an introduction into that particular scene that complements the audio that goes along with it. So if somebody has issues with hearing, they can also, everything is presented in a textual format that they'd be able to read as well. So this is an idea of creating, stunning, engaging visual effects. So this is our 3D model, interactive model of a black hole, and being able to see how different stars would interact with the forces of a black hole and the gases being shredded off of the star. Our science menu in each one of the scenes that we've developed contains a number of different learning environments and this learning objectives. In this one, we show structure of the black hole. This scene here, all of the scenes that we've built have been aimed to align with Webb's science themes. Webb has several science themes that we'll explore, including stellar life cycles, which this is one that this scene focuses on, as well as galaxies over time, the early universe, and other worlds. And so in this environment, we're attempting to show users what happens as a star evolves over the course of its lifetime and the different phases that it goes through. And we try to provide user interfaces that are intuitive to our users to use. So each star that each different mass star that a user can fly off to in this environment, they're able to then interact and show the timeline of the life of that star and how it would change. And this is all based off of data that we've got from our in-house scientists to populate what these stars would do over the course of their life cycle. So there's a lot of information that we've tried to pack into this environment. And one of the things that we've tried to do is also build a bit of gamification into our applications. In the scene that we're seeing right now, each one of these different stars has been unlocked. But in reality, when a user first comes to that application, these are hidden from a user until they've actually gone out to explore each one of these. And as they explore them, they unlock different features that they're able to then experience. And that'll be a little more evident in the scene that's coming up. So in this scene, we have created a simulated exoplanet environment. And as you can see,
has not yet been discovered. Visit an observation lab to reveal the details of this planet.
There's an idea of the system that hasn't been discovered. So we've now introduced the idea of making the user a part of the discovery process. So in the exoplanet scene, there are 3 different types of methods for discovering an exoplanet. And so you would have to fly off to these individual labs where you're presented with each one of those different
Some starlight
options,
when the planet passes.
or they could just fly away.
Some starlight is blocked when a planet passes or transits in front of a star. One way.
So I think the video is paused. I'm not quite sure why. Oh, there it goes.
Press the touchpad to search for planets using the transit method.
So what we're seeing now is actually an example of some of the first releases that we've seen come out of Webb, which are some exoplanet discoveries, and we'll start seeing a lot more of those light curves that show up as Webb witnesses these transiting exoplanets. And I'm not sure why the video keeps pausing, but I'll give it a chance to go ahead and get started again.
You may now visit planet Australia 1C to explore in more detail.
Good. Hey, Chad, this is Matt. Did you want to move on to the Q&A?
Yeah, we could do that. So, yeah, that would be fine, because I know people are probably really interested to just have a bit of a conversation about the telescope as well. So
Sure.
Yeah, let's go for it.
All right. Well, we have microphones, 2 microphones. If anyone has any questions, we do have some from social media that I can throw out, but want to give anyone opportunity to ask a question of our James Webb folks. Can we put them up full screen here? Yep. Okay. All right. Our own Dr. Webb, I think, is going to the microphone, so this is good news. This should be a good question.
Will you also be making these videos available in a planetarium setting? Because I feel like sometimes the VR is a little too personal. So planetarium settings would be great.
Yep. So that's a very good question, and I completely agree. VR has its limitations. There are benefits, and there are certainly drawbacks to it as well. I will say that in the past we have created and released a number of video sets that go out for distribution out to planetariums. I don't know if Kelly, if you can speak to any plans that we might have for Webb-specific creations, video creations that we might be doing for planetarium purposes.
Yeah, so there's a whole astro visualization group that includes doing videos for planetariums. I know it wasn't the first priority when we were doing the Webb's first images because there was a lot of effort just to get everything out, and now I think we're just catching up. So I don't know exactly where they are with those at the moment, but it is one of our future plans.
Okay. Questions? Otherwise, I'll go to social media. All right, let me throw one at you from social media. So, how close of a view could the James Webb Telescope get of a nearby exoplanet?
So I think the closest exoplanet that we could see would be around our nearest star system other than the sun, so Alpha Centauri. And there's actually plans in the first year to look around the star Alpha Centauri to see if there are any planets around that system that we are missing. And so one thing that Webb has is it has a coronagraph, which is basically a disk that you can place in front of the star, and you can block out the bright light from the star to see if there are any faint things around it. So actually, we can see exoplanets pretty close to Earth, 4 light years or something.
So I bet you can imagine the next question that's coming. So. Is it possible that the James Webb Telescope could discover intelligent life in the universe?
Ooh, gosh. I mean, anything's possible. Maybe there will be, one day ET will show up and wave to us through the telescope. The problem is when we're talking about sort of astrobiology and looking for signs of life, it's really difficult to do. So Webb is good at characterizing the atmospheres of planets, but mostly just the bulk composition of planets, especially the smaller rocky ones that we think life would exist on, as opposed to big puffy Jupiter-like planets that are orbiting inside the orbit of Mercury, something like that. So maybe as we understand the instrument more in a few years, we'll start pushing down into those regimes. But for right now, we're just sort of at the edge of understanding the atmospheres of planets around other stars.
Okay. Audience questions? Anyone? I can keep going. All right, here we go. So this is kind of an IT related one. How much data, and if you don't know, it's okay, but how much data has the system stored since it began sending images?
Oh, that's a good question. Gosh, let me bring up my notes here.
No pressure.
No, I don't have it written down. So yeah, there's all of the data from the James Webb Space Telescope is stored in our MAST archive. So if you want to answer that question, you can go look it up yourself, but I don't have the number off the top of my head and I don't have it handy.
Okay.
So there's a non-answer.
All right. I hope you have it backed up. That's good.
I'll actually jump in on that. Let me see if I can find it real quick. Because we do on our website, www.webbtelescope.org. That's our public outreach website. That is one of the frequently asked questions that we have. How much data will Webb transmit each day? The answer that we've posted is that Webb can downlink at least 57 gigabytes per day, recorded science data per day, with a maximum data rate of 28 megabits per second. So you could do the math to try to figure out since launch how much that totals up to, but that should give you a good idea.
Our IT security folks want to know if it's encrypted. I'm kidding. That's a joke. That's a joke. It's a joke. Okay, we have a question from the audience. Go ahead, Michael.
Hi, thank you. Chad, I'm really curious about the VR experience on mobile applications. We had a partnership with Google Cardboard a while back, and considering accessibility and how incredible this tool is, it seems really powerful. I'm curious if you are considering building a phone application, or maybe what are your ideas on how we can engage with this using kind of a downgraded VR device like Google Cardboard?
Yeah, this is definitely an area that when we first started thinking about this project, we struggled with quite a bit. And there were two different directions that we could go. We could go in the direction of building something that's aimed towards a telephone use that could be dropped into a cardboard. But that also has its limitations in terms of, the exploratory nature, in terms of, the amount of data, the size of the application that we could build. And we had already started to sort of have these concepts in mind of allowing a user sort of free reign of their environment and making it a heavily exploratory experience for them. So we did tack in the direction of making this for the headsets themselves, in the hopes that as they are now, the price would come down, the tethered to the computer would sort of be broken, and they'd sort of have their own standalone headset that you don't have to have plugged into a computer. And that started to happen, but there's still, it's still not in large scale use, widespread use. So there is still the limited reach. We do have some plans, or at least some conversations going on right now about how we might be able to take some of what we've learned from this VR experience and turn that into a standalone application. Prior to the video starting to cause some issues, there was actually another section of the video that went into our latest development effort, which was on Webb's discoveries. So periodically we will be going through and we'll be updating, but a user is able to, in that environment, take control of the telescope and point it around in the night sky to be able to look at what some of those discoveries had been. One thing that we've thought about doing is a phone-based application that uses the ability to know where it's pointing and to be able to have a user be able to do that without the VR headset. So they'd be able to hold their phone up to the night sky and be able to see, what are the observations that Webb has made and sort of make those discoveries on their own as well.
Okay, I think we have another audience question. Go ahead.
Yes, hi, my name is Jessica. Thank you so much for demonstrating that. I think it's really cool. So my question is twofold. One is, you already kind of briefly touched on some of the limitations, but specifically in terms of accessibility, I know Dr. Lepo, you mentioned, sonification, which was really interesting, and tactile stuff, but what might be an accessibility application or lens that you might be looking forward to in terms of WebbVR? And then my second question would be, how might we help prepare future scientists to be developing things like this? Thank you.
That's a really good question. Thank you. The accessibility part it's been one of the things that I've struggled with quite a bit with the VR application. VR is, initially when I started developing this, the idea of creating an accessible product wasn't the number one thing on my list. And, but it was just, this was an area that was interesting to me. It was new. Commercial headsets weren't out yet, and it just seemed like a great way to be able to reach audiences through a medium that we're not used to using. So we have struggled to some degree to figure out how to make this product as accessible as possible. So some of the things that we've done so far, like I said, is trying to make sure that our contrast levels in the application have high contrast, especially when we're talking about putting text on the screen with other images and whatnot, so that if a user has to read something in the environment, they're able to see it more clearly. In addition to whenever we're presenting something in audio, that we also have it as an option to them to read as text. We also include some features where if a user doesn't have good body mobility, or say they might have to use a wheelchair and they can't move their body as freely as they would like, meaning they can't necessarily turn them. One of the advantages of VR is that it's a 3D environment. So if you turn yourself around, you're turning around in the environment as well. Not everybody can do that. So we've added accessible controls that allow a user to just press a button on the touchpad on either side, which will actually rotate the camera around. And that's actually, we've seen that in use from people who have been wheelchair bound to be able to use that application. But it's still limited. So it is, and that's one of the things that I struggle with. In terms of developing for the environment, it's really tough. 3D development is a really challenging space to work in. I didn't have any experience in the 3D development space. I was a web developer and a designer before I started this project. And so really getting a sense of working in 3D gaming environments is a great place to start. Learning how to render volumetric clouds, learning how to do 3D modeling, texturing, shading, lighting, all of those things are really important, because the one thing that I think has made our application stand apart from a lot of the applications that we've worked with, that we've tried out, is really that engagement and that excitement and being able to create environments where a user feels like it's close to real. I've tried a lot of VR applications and they don't give that sense of compelling, like drawing you into it. And we've tried really hard and spent a lot of time on making that emotional connection with our users. I showed a picture earlier of us demoing to a bunch of kids. And I will never forget this, but one of the young girls who tried this headset on, she took the headset off and she looked at me and she said, "That was the most amazing thing I've ever done in my life." And then her expression went from pure joy to just sort of sadness, because I think the realization that she would never experience anything so cool in her life kicked in. and so it's sort of like, I wish I could follow her and see if this touched her in the way it seemed to touch her in that moment, right? So my suggestion is, work on creating those realistic environments and think about it from how you emotionally connect with people, in addition to the actual learning objectives that you're working on.
Okay, we have another follow-up from Michael. Go ahead, Mike.
Yeah, you spoke about how this tool's supposed to help and explore, and we see all of those applications. I'm really excited about it, but we're a very large university. I'm curious if you all have seen any examples of how we can use this tool in courses that aren't explicitly astronomy courses or astronomy labs, where other particular subject matters could benefit from leveraging this and this experience.
So I think there are many different applications for VR technology, engineering, medicine, architecture, just to name a few. The key, the challenge is that it's still relatively new. It's the way that there's no standards yet, right? You go to your phone now, and you could pick up anybody's phone and you could probably figure out how to open it. You could probably figure out how to find a photo, open a photo, zoom on the photo, move it back and forth, up and down. There's sort of these mechanics that have become standardized for that technology. And so it makes it easy for people to use that technology. The VR environment in some ways is still rather the Wild West. Those standards, those understandings and mechanics are different from place to place. So I think it's going to take time before the technology is easy to use in a reliable way in an educational environment, because you need to know when you put a headset on how you interact with the environment, right? And so one of the goals when we developed WebbVR, what we noticed quickly was that people were struggling to figure out how to use the controllers and fly around. So we had to step back and say, make it easy as possible. And we stripped out a lot of what a user could do, and we turned it into point and click, right? Point and click. So when you want to move, you just point in the direction you want to go, pull the trigger, and that's how you move. So it's sort of thinking about those things. Yeah, there's lots of applications for it, but there are definitely struggles to figure out how to integrate it into education.
Okay, I think we have time for one more question. Anyone? I got a couple more on social media I could go to. All right, so this is a question for Dr. Lepo, I think. If you were going to launch another telescope, what would you change about the design?
Oh, that's a good question. If I were to change the design, let's see, I would build a telescope like Webb that has a big giant mirror, but change the wavelength, right? So whenever you look at space with a different wavelength, you learn different things. So Webb is really good at studying these dark, dusty star-forming regions. It's good at studying galaxies at the very edge of the universe. But there's not a lot of coverage in space right now at ultraviolet wavelengths. So that's light that's just bluer than what our eyes can see. And it would be really, really cool if we had a telescope just like Webb, but at ultraviolet light. That's what I would do if they put me in charge of telescopes. Maybe they shouldn't.
You never know. Okay. I'm being told we have time for one more question. If there's no one in the audience, I have one more social media question I can get in. So here it is. Given the complexity of the James Webb Telescope, what were the odds of it failing from its launch to its final destination?
Gosh, I mean, it was non-zero, which was really scary, right? So this telescope has spent so long in development and testing. All of the engineers were really confident. But as a scientist, I didn't want to get my hopes up. There were lots of single point failures on this telescope. We'd never done anything quite like this before. But it's really a testament to all of the hard work that went into the telescope that it all went almost flawlessly. So big props to all of the people who spent their careers designing the telescope.
Okay, well, I think that's it. And I just want to congratulate and thank Dr. Lepo and Chad for joining us today. We really appreciate you taking the time to be at our conference. It means a heck of a lot to us. And I just want to mention, too, a big thank you to Dr. Simpson and Dr. Webb, who were here today and helped kick this segment off. So thanks again. Let's give a big round of applause to our visitors from James Webb.
Thank you for having us. It was great.
Yeah, thank you so much.
All right, guys, stay tuned for the next installment.